In this video, we'll see another example of using the find command to work with arrays, both one-dimensional and two-dimensional. So let's get some values in here. So let's say more with find. And this is the same list of prices I had before, so you might still have those. But if not, go ahead and copy those down. And I might want to sort through these and say, where are the, let's see, task 1, let's say. Where are prices greater than 30? And we're going to report this in a nice user-friendly style using fprintf. So the first thing I need to do is find them. So let's save these as locations of cars greater than 30. Find prices greater than 30. We don't need to see it. I'm only going to show the user my nicely formatted output. So all of the rest of this is going to be behind the scenes. But this tells me the locations. Gives locations, and now in order to find out what those prices actually are, I need to use the matrix with parentheses to call that. So let's say values, let's call these good ones. The good ones, maybe, I don't know, maybe you want to spend more than 30,000 on a car, but this will be in the prices matrix. Look up the values associated with these locations. Okay, so good ones now has prices. It has a subset of prices in it. That's what I wanted, and now let's format it nicely using fprintf. Format output using fprintf. And we'll do that by, let's build a sentence. Fprintf car number blank. And so I need the location. But I want that to be an integer, so let's just use f. And I'll use the 1, and because I know I have less than 10 of these, so 1 digit will be enough. That's what the 1 point means, and the 0 means don't give me any decimals. So it has, let's say, is, and then a $sign, and then another blank here. All of them are 2 digits, so let's say this, comma, $1,000, period, and new line. And now I'm going to tell MATLAB where to get the things to put in those blanks. So the first blanks is car numbers. So like car number 1, car number 7, those are the locations. So I'm going to put in locations that are greater than 30. Remember, that's where I saved it. And then I want the price of each of those. So that's going to be good ones. Nope. Yeah. Good ones. That's where I saved them. So let's go ahead and run that and see if I did it correctly or not. So run section. Oops. Did I not find any? Oh, I think I know what I did wrong. First of all, I forgot the percent sign here. But I think that's still not enough. So I'm going to run it anyway. Let's clear this. I think it's going to give me a similar problem again. Yeah. Because I didn't make this into a matrix. So I need, because they're arrays with multiple values in them, I need to create a matrix out of this. So let's make this into 2 square brackets. I've got a semicolon because I want it to be in rows, and that matrix now contains all of the values that I need. So remember, let's just, hold on a sec. Let me show you this real quick. This is what this matrix looks like, right? So when I use it in an fprintf statement, it's going to go down. It's going to say car number 4 is 75,000, car number 5 is 37,000, etc. And that's what I want. So I have to build this matrix so that MATLAB knows where to get all my values, because I forgot. They're not as simple as just scalars. Let's run this section again. Double check. Car number, and then I have this. My blank starts with a percent and ends with an F. Same here. Forgot the F. Ooh. All right, double check. Percent F, that's all part of it. Let's clear this and run it again. Ah, there we go. Car number 4 is $75,000, and so on. There's a lot of little things to remember with fprintf. But, so that's how we can use formatting to give us a nice output. That way we have human readable sentences, which I like. All right, let's keep going and say task number 2. Now we're going to play with a 2-dimensional matrix. So far our prices was just a 1-dimensional list of prices, but let's look at a 2-dimensional array. Find in a 2D array. So let's create some years, and I need to know how many to create. It's a 1 by 9, so I need 9 years. Let's say 2006, 2010, 2001, 2019, 2015, I don't know, 2014, 2013, and 2015 again. Is that 9? 1, 2, 3. That looks like 9 of them. So now that I have these, I'll call this years actually. Doesn't matter what they are. But if you want yours to come out like mine, that's okay. And I'll build a two-dimensional array out of the prices and the years. So I want these to be in a column. So I'm going to use prices as a column and years as a column. Let's just run this real quick and look at our cars array. And you can imagine if we had a more information about each of the cars, we could have more columns. But this is prices and years. So now we want to say, let's see, use find to locate cars under 30K that are 2012 or newer. Okay, and I'll call this best cars. So first we're going to find the locations using the find command. Best cars is the find command, and I want to just search the first column. So I'm going to search cars, all rows, column 1, and I want to know where is that less than 30. So where's the price less than 30? And in cars, all rows, column 2, where are they newer than, so greater than or equal to 2012. I don't need to see this. I'm going to format the output nicely using fprintf. So take a look at that structure and make sure you follow all the individual pieces. We're saying in the cars, but I just want to search column 1 for this one. Where is column 1 less than 30? And where is column 2 greater than or equal to 2012? Those will be the best cars, but remember that just tells us location. Tells us locations of the cars we want to look at. Now we're going to make it pretty. So display in a readable sentences. Let's take a look. To do this, I think it's easier. Remember how before we made a matrix out of it, except I forgot and had to go back and do it? Let's make the matrix first, and then it'll be easier to make our fprintf statement. So I'm going to make a matrix that says, here are all the cars that I want to use in my fprintf. And for the first row, I want all of the prices of all of the cars. In fact, let's put the location in. So I'm going to have location as row 1, prices as row 2, and year of the car as row 3. That's what I'm going to do here. So make a matrix where the first row is all of the locations. Remember, the locations are saved in the array called best cars. It's a column, and I want it to be a row, so let's make it like this. Oops. Second row will be all of the prices. So in the prices matrix, look up all of the locations best cars. And I think that's already going to be a row. And then finally, years of all the best cars. And that, again, that's also going to be a row. Let's run this and look at this matrix real quick. This matrix called results to see how did I do. Was there really only one car? Okay. Interesting. Well, you could play around with this. Maybe we should make this 07 or something to get more cars. Sure, let's do it. I guess there weren't very many that were both. So let's just have more cars by changing the year. Run section again. Okay, now I have a couple to look at. You can imagine a user interface where the user picks the year that they want and the user picks the price that they want. But we'll do more complicated examples later. So we've done the work of building the matrix. Now we're going to display cars that meet your criteria. And then let's make a, oop, there we go, put a space. And then here we'll do our fprintf car number, oops, car number percent 1.0f costs $, percent for the blank 2.0 f comma 123 model year, and then I'll put the third blank. Let's just say 0.0 and then a new line. New line, close quotes, and tell MATLAB where to get the data. The data are in the matrix we called results. All right, let's suppress this output and run this. We get a nice readable sentences, so that looks good. So here's how you can use find with either a one-dimensional array or a two-dimensional array.